All right. Last thing. So we're going to look at doing the t-test. So the only difference between the t-test for hypothesis testing and the z-test for hypothesis testing is we don't know the standard deviation. So we have to find it from the actual problem. The rest of the process is very similar. One note, when you're doing the t-test, you really want to use the critical value test, not the p-value. Problem with the p-value is it's to get the exact percentage is very difficult with the t-test, just because it's varies so much. So going the critical value is going to be a lot easier. So I'm just going to do the critical value with these. We're not going to do both. So. All right. So the same concept. It's got to be a normal sample, and it's got to be a normal population or a larger sample. Typically, when we're doing the t-test, we're dealing with smaller numbers. So you either have to make the assumption that it's a normal distribution or look at it. The ones on the test and the ones on the review test will be normal distributions. So you do not have to prove that. So we're going to make the assumption that anything we're going to work with is going to be a normal distribution. If you're going to do this in real life, make sure it's a normal distribution before you do it. So, all right. So step one, same concept. We have to figure out the null hypothesis and the alternate hypothesis. So the null hypothesis typically is the mean equals whatever they're giving you. So when we're looking at null hypothesis, even with the z-test or the t-test, it's really what is being claimed. So whatever that claim is what you're going to look at. And then my alternate hypothesis is what you believe to be true. So either it doesn't equal what they're saying, it's less than what they're saying, or it's greater than what they're saying. So we still have a two-tailed, the left-tailed, and the right-tailed test. Step two, once we determine those, we have to figure out what. I always wait for the second one. Decide on what the significance level we're going to test. So if we're going to do a 5%, 1%, 10%, whatever it happens to be. Remember, when we're looking at two-tailed tests, we have to cut that in half because we have it on both sides. When you're looking at a one-tailed test left or right, you use that entire significance level. So that does make a difference. Depending on the t-table you're looking at, I don't know the one in your book if it has the one tail and two tail. So like this is the one I use typically online. You notice it has the one tail and the two tail there, so you can actually look at the breakdown. If I don't know in the book if it does. What's the how many times the book? Yeah, so in the book you'd have to split it in half. So I will have for the test, I will give you a copy of the Z table and the T table. So the T table you're going to get is going to have this. So it'll actually have the split of the T, one tail and two tail. Because I'll actually use this one. So, all right. Next step, we have to compute the test statistic. So in this case, we're using the T. So it's the top is basically the same. It's the mean of the data minus the mean that they give us. The bottom changes slightly because it's the sample standard deviation, not the standard deviation of the population. So it's the sample standard deviation divided by the square root of the number of samples that I'm looking at. Also remember on the t-test, actually I think it tells you in the next step anyway. That doesn't. Remember on the t-test, we're looking at degrees of freedom. So the degrees of freedom is n minus 1. So just keep that in mind when we're looking at the list. So it's always one less than whatever the sample number is. All right. So critical value approach, I said I'm just going to look at the critical value for this one. So we have our two-tailed. Remember, it's the sample, the significance value divided by 2. If it's one-tailed, we just use the significance level. So when we find that critical value, if it is within that range that I'm looking at, we reject. And if it's not, we do not reject. So this is identical to what we did with the Z tables. So nothing's really changed there. All right. Any questions with that? All right. I'll go back. All set? Okay. All right. Since we got it, let's start using it. So this one we're looking at acid rain. So what information, based on this, what do they give us? So what is my null hypothesis? So my, let's see. Yeah, the mean is going to be 6. So your null hypothesis is always got to be equal. Okay, so let's say non-acidic lake is pH greater than 6. So 6 is going to be the break point between them. So yes, it does say greater than 6 in there, but again, the alternate or the null hypothesis is always going to be equal, because otherwise it makes it really complicated to do the other side of it. All right, so we've got that. What is my alternate hypothesis? So we're trying to say that high mountain lakes in the Southern Alps are non-acidic. So to be non-acidic, it has to be greater than that, right? So it has to be greater than 6. Or greater than the null hypothesis. Okay, what kind of test is this? This is a right-tailed. Do we have right-tailed? Okay. And what significance level am I looking at? 5%. So yeah, 0.05. Okay. All right. Even though you're not going to have to do this in the test, I figured it's a good practice point to do it now, because you're going to have to do it on the actual final exam anyway to find the standard deviation and the mean. So we're going to look at it for this set. So here's the pH level for 15 lakes. Find me the mean and the standard deviation for this. Remember when you're doing if you're using samples, the standard deviation calculators, this is a sample. So make sure you choose sample and not population. So I've got a standard deviation of 0.67. So my S is 0.67. And my mean is 6.6. All right. Anybody have trouble finding those? Those who did it. All right. So we've got that information. So what's the next step I need to find? I need to do. Yep. Now we got that. We got to find the test statistic. So remember, T in this case is the mean, the sample mean minus the mean over the standard deviation divided by the square root of n. So in this case, we've got 6.6 minus 6 over 0.67 divided by the square root of, I think it was 15. 15. So I went to a session yesterday, the class that they're changing this class into. They're getting rid of this class and they're changing it into quantitative reasoning. They're changing a lot of little things. But the program that they're using has Desmos built into it. So, which works out nice. All right, so when we do this out, we get 3.47 is my T. All right, so now that we got that, we want to find our critical value. So we're doing a right-tailed. So that means we're looking in this section over here. And we were doing it at a 0.05 significance level. So let's go to our t-table. So it's a one-tailed 0.05. So that means we're looking right there. And what was my degrees of freedom in this one? 14, because it's one less than the sample size. So we go 14, we're going to go over to 0.05 for the one-tailed, and we get 1.761. Notice the reason why we're doing critical values and not the p-values, there's no p-value in this problem. All right, there's no problem, there's no percentages. So to do the actual p-value, we'd have to look at a couple values and then we have to figure out its ranges between it. It's a lot more steps. So it's just as easy, since this case we have the critical values for the critical values. All right, so we're looking at the 1.761. 3.47 is in the rejection region. So we're rejecting the null hypothesis and we're accepting, basically saying that the alternate hypothesis is true. So in this case, what we've now shown is that our lakes are classified as non-acidic. So six, so are acidic. Yes.
Can you show us one more time on the table, on the T table, how you got the 1.7?
Yeah, let me do it this way real quick. Let me copy it.
I was trying to follow along.
No, it's fine. I'm going to copy and paste this so this way you can actually, I'm going to draw right on it. All right, so we're looking at a one-tailed 0.05. And then we're going down to 14 because it's one less than the sample. So we look at that column, and that's where the 1.7 is. No problem. Like I said, this is the T-table I'll give you for the test. So you'll have the one-tailed and the two-tailed there. Because if it was two-tailed, I would have used that one instead. All right. Any questions on the process for that? So that's basically how I'd want to see it done. I want to see the alternate hypothesis, the null hypothesis, the significance level, what tail it is. You're not going to have to do this on the test. You will have to do this on the final exam, though. Because what I'm going to do, the final exam isn't going to be a breakdown of like chapter questions. So like I could give you a problem like this and test that you can find the mean, find the standard deviation, find like I can do all that stuff in one. So the final exam is going to be more questions like that, where you're going to have to do a bunch of like steps to do it. But it's testing all the stuff that we've done throughout the course, the whole course. So it's like I might give you a problem like this and ask you to create me a histogram for it and things like that. So this way I can see you're testing that it's the normal hypothesis and stuff. Yes.
Are we going to get a practice test for the final?
Yes, I'll have the practice test done for you probably on Tuesday. My goal is to work on it today, so it should be done by Tuesday. So you'll have at least a week to study for it before the actual review class, which I will do the review class before the final exam, which is on Thursday. So, but yeah, you'll have a review test for it. All right.
So what day is that right now?
The 11th, I think it was. Yes, May 11th.
You still got a note card for that?
You got a whole sheet of paper for that one.
Fancy.
Or you can bring all your note cards as you've had, if you kept your note cards. Because it basically works out to be a full sheet of paper.
How many sides of the sheet of paper can
Both sides,
Okay.
just like both sides of the note card.
I'm just asking because in my high school, some of my final exams,
Yeah.
I used one side of the.
Yeah, you're allowed both sides. Because basically what I designed it so that if you have your note cards basically make a full sheet of paper. Because if you do 4x6, it's basically 8x12, which is 8 by 11. It's close enough. So that it works out to be the same. So you could use your 4 note cards or you can make up another one for the final exam. Your choice. All right. So, and then the T-table, the T-score there, you do not have to draw a picture. I think the picture actually really helps you figure out like where it's falling, but you do not have to draw a picture. I do need to see though the actual like line statement of what's going on, right? Because that's the conclusion of your hypothesis test, which is the most important part. All right. let's look at this one. This is more similar to what you're going to see on your test, where it's going to give you the problem. And if you notice, it's giving you the mean and the standard deviation for this test. All right, so set up the first parts of it. So find me my null hypothesis, my alternate hypothesis, and my significance level. We'll start with that. All right, so what's my null hypothesis for this? Yep, my mean is 4.55. What's my alternate hypothesis for this? Huh? It doesn't equal because it says differ. So my mean would not equal 4.55. Okay. And what significance level am I looking at? 10%, 4.1.
So whatever was different.
Not the same. So that means not equal to. Because when we're saying different, it means that it could be less, it could be higher. We're just saying it's not what they're saying it is. All right. If it's going to say lower or higher, it'll say greater than that or less than that, things like that. All right, now that we've got that information, so now we need to find our t. So actually, I'm going to write that here and then I'll copy and paste it over. So the mean that they gave me was 4.760 minus the 4.55, which was the mean we started with. And then my standard deviation for my sample is 2.97, and we're dividing this by the square root of 20. So I got 0.41. So now I'm looking at a two-tailed test, right? So that means I have the value over here and the value over here that I'm looking at. So if we look at our t-table, we're looking at two tails. So two tails. We're looking at a 10% for two tails. And then we had, in this case, it was a sample size of 20, correct? So my degrees of freedom is 19. So I'm looking at 19. So that's going to be a 1.72. So that means I have negative 1.729 and positive 1.729. And 0.41 is somewhere in here. So I do not reject. Yes,
A little bit of a stupid question. Why are you drawing the line in the middle? Is that just to show where the middle is?
Yeah.
Okay.
that's just the mean.
I wanted to make sure it wasn't important.
No, it's just the mean. So the average viewing time average viewing time doesn't significantly differ from the 4.55 hours. All right. Notice there's no real major difference between the one-tailed and the two-tailed tests. Concept's the same, process is the same. Yes.
On the test and on the final, are we going to be able to still choose between P-test and
Mhm.
T-test? Or do we
Yeah.
have to do certain ones?
Nope, you can choose. Like I said, I would not do the p-value if it was a t-test. So I'm not even showing you how to do it because the process is a lot longer. So because basically what you end up doing is you have to look for these and then you have to compare it back to the probabilities and you're looking at saying, well, it's somewhere between here and here, and this is the number that I got. It's really easy if we use technology to do it, to actually do the calculations. But using a table, it's a real mess. That's why I'm just showing the critical values for this one. But for the z-test, you could use either one because you have that information. So. All right. Yep, this is this one. Okay, so find me my null hypothesis, my alternate hypothesis, my significance level, my mean, and my standard deviation for this. What's my null hypothesis for this one? Yeah. So we're going to say the mean is 180. And what's my alternate hypothesis? I want it greater than that. So notice they're not saying that the average of the golf club is 180. We're saying that we want it to be greater than that, so we just set our null hypothesis to be equal to that. Same thing we did with the lakes, where we set the null hypothesis to be equal to the 6, which is the split between acidic and non-acidic. And then we're just saying that it's going to be greater than that for my null hypothesis. What was the standard deviation for this one? Yes, 2.73. And what was the mean?
186.
Okay, so 182.7. Round to one place. Remember, so your goal is always one more decimal place than the problem gives you. So in this case, since the problem is no decimal places, one place is fine. If you did 6, 7, it's not a big deal. It's not going to change your calculation that drastically that it's going to make a difference. But just for consistency's sake, that's the easiest way to do it. Yes.
How many decimal points do we go for the standard deviation? The last problem is 3, but this one's 2.
Well, the last one that gave you 3, I typically always go 2. Again, it just depends on the data. So again, it's not going to make a significant change, that big of a significant difference in it at the end when you're doing the calculation. So it's not that bad. So as long as you go a couple places for the standard deviation, you're fine. The book tends to go 3. I don't know what the book did for this one for mean. Oh, this one actually didn't give you the mean. So. All right, what was the significance level? Oh, I didn't give you the significance level for this one yet. That's why. That's on the next screen. All right, let's look at it. So my first one we're going to look at was significance level of, actually they did 2.7. They did 1 standard deviation this time. 5%, so 0.5 is my significance level. So we'll do A first. All right, so now I need my what? All right, so find my T. Yes.
0.5 or 0.0?
Oh, 0.0. I missed a 0. 5%. 0.5 would be 50%. All right, so find my T. All right. So what kind of tail was this one? right? So we're looking at over here. All right, so now I got to find my t, correct? All right, so let's find my t. So it was a 5% on one-tailed, so one-tailed 5%, and we're looking at what for my degrees of freedom? 5. So right here. So 2.015. And we're at 2.42. So we reject. So we're the average should be greater than 180 yards, which is what he wanted. So he'd buy the club. All right. So question B says repeat part A for a test significance of 1%. Do we have to do the entire thing over again? What's the only thing that changes? The t-table, right? That's really the only thing that changes is that number right there. Okay? Everything else that we did stays the same. So you don't have to redo the whole problem. We're just now going to change that number and look at the 0.01 instead of 0.05. So if we go back to our t-table, and I purposely made it so that we can do this, we're still looking at one table. We're looking at 0.01 this time. So now, same concept, we go down. So now we're at 3.365. So that number right there now is 3.365. And in this case, we're now going to do what? We're not going to reject. So it might not be greater than the 180. Okay. So, and that might just be a coincidence of only doing 6 test shots. If it's a robot, give it a whole bucket of balls and have it go at it. So that's honestly the only difference. So if I give you a problem where I say, find me a 5%, find me a 1%, you don't have to redo all the work. You're literally just doing the last step again. Just checking for a different value. Let's do the nursing home costs. All right, find me my initial information for this one. What's my null hypothesis? What's my alternate hypothesis? It doesn't give you one, right? Okay, so if you were doing this, what would you want to make your alternate hypothesis? What are you trying? What do you believe? What should you be trying to show? Huh? You'd want to say that it's less than that? Okay. You could do less than, you could do more than, you could say it differs. Okay. If you're a person going, you might want to say, well, they're undershooting what it is. It costs way more. It's going to cost more than that. So, in the end, does what you tell me for your alternate hypothesis change the process at all? It changes the tails a little bit, depending on which direction we're going to go with the tails, right? But in essence of finding the mean, standard deviation, the C-score, those things, the real big thing it does is it changes what your conclusion is going to be at the end. Okay? So in this case, they want to test if it's greater than that. So we're going to say that our mean is actually greater than 239. And the significance level they want to do is 5%. 0.05. All right, so find me my mean, my standard deviation, and the t-score for this. All right, so what was our mean?
67.6, right? 26.
Yeah, because I think it was 1 place, right? All right, what was our standard deviation?
59.05.
That sound right to others? I didn't do it. So I'm just to you guys. All right, so now we do our t. So let's see. I'll do this one. So 267, 6 minus, what's the mean? 59. What was the sample? Was it 20? Or was it 11? We got 1.61. Okay. And we're doing a one-tailed test for this one. And we're doing a right-tailed. So we're going to look at, so one-tailed, 10. So that's 1.812. And my 1.61 is somewhere over here. So we don't reject. If we were looking at left, so we're looking at less than, I still wouldn't reject. Because I would have gone negative 1.812 over here, and it's still in the not reject region. And if I had done a two-tailed, so that it would have been over here, I'd have been at 2.228, so I still wouldn't have rejected it. So no matter which direction you wanted to go with this problem, the data doesn't show that it's significantly different from the mean of $239. Yes.
I messed that up, so can you remind me how we pick left versus right?
It depends on the problem. So this one says it's greater than, so that's why it's a right tail. So if it was less than, it'd be a left tailed. And if it's not equal to, that's the two tailed. We have it on both sides. So here's there's the nice little picture for it. And then you can see two-tailed, left-tailed, right-tailed. All right. That's it. We're done. You've successfully finished stats. Any questions you have? I hope the class was at least semi-useful. I hope you got something out of it instead of just saying, oh, another math class, I just finished it. Hopefully when things come up, you can be a little more knowledgeable and say, no, this makes more sense now, which is the goal of this class. So
The practice test is already up?
the practice test is already up, so you can look at it immediately. I'll have the notes and the video up as soon as I get them from Google. So.
So next week we'll do the practice test on Tuesday.
Yep, practice test is on Tuesday. The test is on Thursday,
And
and the last week, the final week will be the practice review on Tuesday. The final on Thursday. I'll be here for 9 both days for the tests, so you can get here a little bit early if you want. So, okay. Have a good week. You too.